Next, we just have a couple of examples from start to finish, like what would a complete problem look like. If you have any questions on these, please reach out to me. When we have a problem that is a definite integral just means that we have numbers. We have numbers here and here. So now instead of just finding the antiderivative, our goal is to find the area under that curve. So our goal is to get a numerical answer. So this is our final answer is some number. So there's an extra step in a problem like this, but we start out the same way. So looking at this problem, 3 cosine x over root 1 plus 3 sine x. And we identified the inside. We have something that's under a square root, so let's make that u. And we need to take its derivative. So we start out kind of the same as before. Oops, sorry. And we start to make our substitution. So first, I'm not going to write anything in place of the 0 and the pi over 2. This example simplifies pretty nicely. So here's what's new. We need to take the 0 and take the pi over 2. So these are x values. So 0 and pi over 2 are x values. We need our new problem to be all in terms of u. But we know what u is in terms of x. We said that u was 1 plus 3 sine x. So what we do is we plug those two numbers, 0 and pi over 2, we plug it into our equation for u. When I plug 0 into 1 plus 3 sine x, I get 1 plus 0, I get 1. So my new lower bound is 1. And we do the same thing for the pi over 2. If I plug in pi over 2 into this expression, sine of pi over 2 is 1. So 1 plus 3, I'm going to get 4. So that gives us our new bound. So we take those two numbers and we plug them into whatever we have for u. That's what we need to plug into. So we have a problem. It's now entirely in terms of u. I need to take the antiderivative. So 1 over root u is u to the negative 1/2. So that becomes u to the positive 1/2, and it's going to be a 2 coefficient. We're evaluating from 1 to 4. So we plug in 4, 2 root 4 minus 2 root 1. Root 4 is 2, so 2 times 2. And we get our final answer is 2. So notice when we have a problem like this, once we get everything in terms of u, we never have to rewrite in terms of x. As long as we don't forget to rewrite these numbers here, then we never have to go back in terms of x. We get our final answer, and that's it.